You may. All right, so we're going to keep going on this. I accidentally did these questions in the previous vector video, so if you're looking for these questions, go back to the vector video. And I got cut off when I was doing this one, so I'll carry on with this. So if I originally had these two arrows, these two tensions pulling me upward, but then I changed this one to be more steep, well, previously, let's think almost percentage-wise. Previously, like 80% of this arrow was to the right. So if it was, 10 strong, 8 of that 10 is getting to pull to the right. But if I change that angle, a much smaller percentage is still pulling to the right. So let's say I still need it to be 8, but that 8 is only, 50% of what I've got going on. I need this to be a lot bigger so that, maybe I need this to be like 20 or something like that, so that the small portion is still 8 because it's less of a horizontal force. Anyway, the answer is A, increases. Question 12, going through it, if I've got forces the same size in opposite directions, my A must be 0, so that means I'm not going to speed up or slow down, and I'm not going to accelerate at all. Now, C and D both describe situations when the object is not accelerating. However, remain at rest is a specific case. So this is true of all A equals 0, but this is a very specific A equals 0. So I would say if the problem said the box must move at a constant speed, that would be my best answer. Realistically, on a test or a quiz, I would try to improve the language of this question before giving it to you. 20 Newton downward force and a 20 Newton upward force act on the object. Same sort of situation. I'm assuming that what they're describing is already gravity, and so if that was 20 and this is 20, then it'll move at constant speed, remain in equilibrium. So again, same thing as before. I would want to improve the wording of this for a couple reasons. So don't stress too much about question 13. All right. 14. A 50 Newton force acts at a 40 degrees below the horizontal. The downward component. All right, this is just a trig question, right? So 50 sine of 40 degrees. 50 sine 40. Hey guys, stop hitting that. Oh, we didn't even need to do that. 50 sine 40. Traffic light hangs from two angled cables. The horizontal tensions must equal each other and add to 0. Yeah. So maybe I'll say select all that apply. If net horizontal force on a sine is not 0, the sine will is not 0. So meaning it's not balanced. Then the sine will lose weight, doesn't make sense. Accelerate sideways is a possibility. Fall straight down is a possibility. Oh, but the net horizontal force. Okay, so we're assuming that it is balanced vertically. If it's no, yeah, so it's got to be D. All right, I'm going to end it there for now.